Hello everyone and welcome back to Manarat Academy. Today we are going to study one of the most useful topics in algebra, the laws of indices. And before we explore the laws, let us begin with the basis. What is an index? An index is also called an exponent or power. It's a small number that tells us how many times a number or a variable is multiplied by itself. For example, 7 to the power of 5 means 7 multiplied by itself 5 times. X to the power of 3 means x is multiplied by itself 3 times. Once you understand how indices work, the rules that follow become much more logical and easier to remember. So let's get started. Law 1, multiplying powers. The rule says if you are multiplying powers with the same base, the indices will be added. Instead of memorizing this rule, let us understand how it works. Now, suppose we have x to the power of 3 by x to the power of 4. Let us expand the powers. X to the power of 3 means x by x by x, and x to the power of 4 means x by x by x, x multiplied to itself 4 times. Then we are going to collect or combine all the factors all together. As a result, we will have x multiplied to itself 7 times, so we can write it as x to the power of 7. That's why we add the exponents. Let us take another example. A to the power of 6 by a to the power of 2. Look at the powers. Are the bases the same? Yes. Is the operation is multiplication? Yes. So we're going to follow this law, multiplying powers. When we are multiplying powers with the same base, we are going to add the indices. So we're going to write or keep one of the bases, and we are going to add the power. 6 plus 2 equals to 8. Now let us learn the second law of indices. This time we will discover what happened when we divide powers with the same base. When dividing powers with the same base, keep the base the same and subtract the exponents. But why do we subtract the exponents? Instead of memorizing the rule, let us understand where it comes from. Let us take this example. X to the power of 5 divided by x to the power of 3. Let us expand this calculation. X to the power of 5 means x multiplied by itself 5 times. Divided by x to the power of 3, which means x multiplied by itself 3 times. Now let us compare the numerator and the denominator. Each x in the denominator matches an x in the numerator. Since any non-zero number divided by itself equals 1, each matching pair cancels out. We cancel x from the numerator with x with denominator. We keep canceling out. After canceling 3 pairs, only 2 pairs are left. So we write x by x as x to the power of 2. And this clarifies the idea. When you are dividing powers with the same base, we subtract the exponents. 5 minus 3 equals 2. Now let us take another example. B to the power of 6 divided by b to the power of 4. We keep one of the bases and we subtract the exponents. 6 minus 4 is 2. One more example. 9 to the power of 5 divided by 9 to the power of 2. We keep one of the bases. We subtract the exponents. 5 minus 2 is 3. Now let us study law 3, power of a power. A to the power of m all to the power of n means amn, where m and n are powers. Let us take this example to understand the law. X cubed all to the power of 2. The outside exponent 2 means x cubed is multiplied by itself twice. This means x cubed multiplied by x cubed. Let us expand each bracket. X cubed means x by itself 3 times by x cubed x multiplied by itself 3 times. There are two groups of x, so there are 6 x's altogether. So it can be written as x multiplied to itself 6 times x to the power of 6. That's why we multiply the powers. Let us take another example. Y to the power of 4 all to the power of 3. We multiply the powers. Y, we multiply 4 by 3 equals to 12. 11 to the power of 4 all to the power of 5. We multiply the powers. 4 by 5 equals 12. So 11 to the power of 12. When one power is raised to another power, multiply the indices. Now let us move on. Law 4 of laws of indices, called the power of a product. The law states that if a product is raised to a power, the exponent is applied to every factor in the brackets. Like in this law, a, b, all to the power of n equals to a to the power of n by b to the power of n. Notice that the exponent is outside the bracket. This means that it affects everything inside the bracket, so every factor receives the same exponent. Now the question is, why do we need this law? And before looking at numbers, let us see why this law is so important in algebra. Let us take some examples and start simplifying them to understand the importance of this law. Let us take this example, xy all to the power of 4. Now, can we multiply x and y first? No, we cannot, because both of them are variables, so they cannot be combined. The only way to simplify this expression is to apply the exponent to each factor. X will take the exponent 4 and y will take the exponent 4. So the simplest form of this expression is x to the power of 4 by y to the power of 4. X to the power of 4, y to the power of 4. This is exactly why we need the power of a product law. Let us take another example. This time we have 3a between brackets all to the power of 2. Same as the previous example, each factor inside the brackets will receive the same exponent. 3 squared by a squared, and the product will be 3 squared is 9 a squared. This is how to simplify this expression, as well as a and 3 cannot be multiplied into a single simplified term. Now let us look at a more challenging example. Now simplify this expression to x squared y all cubed. So each product of them will take the same exponent, as we cannot multiply 2 x squared and y. And instead we apply the exponent to every factor. 2 will receive the same exponents, as well as x squared and y. 2 cubed by x squared all cubed by y cubed. Now let us simplify. 2 cubed is 8. Here we apply power of power. The previous law just now we studied. We multiply the powers all together, 2 and 3. So it will be x to the power of 6, then y cubed. Without the power of a product law, this expression cannot be simplified. Now, what about numbers? Now you might ask, if the factors are just numbers, do we really need to distribute the exponent? Now let us investigate. Consider this example. 2 by 5 all to the power of 3. Method 1, we can multiply first the numbers inside the bracket. 2 by 5 is 10. Then we apply the exponent. Then 10 cubed will be 1000. This is one method. The other method 2, is to apply the power of a product. We distribute the exponent. So 2, it will be 2 cubed by 5 cubed. Then 2 cubed is 8 by 5 cubed is 125. Therefore 8 by 125 is 1000. Both methods give exactly the same answer. So why do we learn this law? For numerical expressions, you have two options. You can multiply first and then raise the power, or as in the second method, you can distribute the exponent first. Then both methods produce the same result. However, in algebra, multiplying first is usually impossible because the factors contain variables. That's why the power of a product law is essential. It allows us to simplify algebraic expressions that cannot be simplified in any other way. Now let us finish today's lesson with the last law of indices, law 4, zero index. A to the power of 0 equals 1, where A is not equal to 0. Rather than memorizing this rule, let us prove why it is true using the law of indices that we already know. Let us recall the division law of indices. A to the power of m divided by a to the power of n means we are going to subtract the indices. Now consider the case where the indices are equal. A to the power of 5 divided by a to the power of 5. Applying the division law, we subtract the indices. 5 minus 5 equals 0. Now a to the power of 0 equals 1. Now evaluate the fraction itself. Any non-zero number divided by itself is equal to 1. Therefore, a to the power of 5 divided by a to the power of 5 equals to a to the power of 0 equals to 1, where a is not equal to 0. This result is true for every non-zero base. Let us take examples. Now 7 to the power of 3 divided by 7 to the power of 3 means 7 to the power of 0 equals 1. So any non-zero number raised to the power of 0 equals to 1. 100 to the power of 0 equals 1. 25 to the power of 0 equals 1. 33 to the power of 0 equals 1. And remember, this rule applies only when a equals to 0. Now let us quickly revise the 5 laws of indices we studied today. Multiplying powers with the same base, we add the indices. Dividing powers with the same base, we subtract the indices. Power of a power, we multiply the indices. A power of a product, When a product is raised to a power, we apply the exponent to every factor inside the bracket, and any non-zero digit is raised to the power of 0 equals to 1. Now test yourself. Try these examples and questions on your own. Pause the video, work them out, then check your answers. Now let us check the answers. How many did you get correct? Let me know in the comments. Now you have mastered the 5 essential laws of indices. In our next lesson, we will learn about negative indices and fractional indices. Thank you for watching, and I'll see you in the next lesson. Goodbye.